Okay, hello everyone. It's me again. I'm Doris from PSE team, and I'm going to talk about Messi, like in the technical side. So yeah, it's the same PPT as like the introduction, so I won't like go through it again. So it's just the on-chain voting protocol, and you can check it out on the previous PPT to know the background and how do we decide to make it, and how like we decide the structure. So when running the Messi, like first of all, you need a trusted coordinator. So the coordinator will deploy the contracts and deploy a poll and starting the voting period. And also like they will choose the user from signing up. And during the sign up period, everyone who fulfill the requirements could be able to sign up to the contract. And then during the voting period, that everyone could submit messages such as the vote message and the key changing message to the Messi contract. And after the voting period ends, the coordinator will process the messages and tally results and upload to the chain, and everyone could verify it. So the architecture of the Messi project, the Messi protocol is like this. First of all, there are circumcircuits because like the messages, the results are like building on top of the ZK snark, the zero knowledge proofs. So we built some circuits for the processing messages and tally votes. Like so far, actually, we also built one for non-QV, for non-quadratic voting ones. Like previously, only the quadratic voting ones there. Yeah, and there are smart contracts. And if anyone's wanna like building on top of Messi, this is the place like you might modify it the most. Like first of all is the Messi contract, like it's controlling all the logics happening in Messi. And the second is the poll, like you can submit a message to it. And then the gatekeepers. The gatekeeper is like gatekeeping users from signing up. And the message processor is processing the message. That it's mainly for the coordinator to run it. And also the tally votes contract. So besides that there are several TypeScript libraries. So there are domain objects like containing logical container of purely domain information such as the public keys, private keys, the key pairs, and also the structure of the commands. Like the commands is a part of the message. Like in a message you submit that there are command and your signature. So, and the second one is the crypto. The crypto package like holds the abstractions over cryptographic, such as the ACU, and I will explain the ACU later. So the third one is the core package containing the smart contracts logic COM for local processing. So like you can imagine it, like there are TypeScripts that pulling the data from the smart contracts and then like build a whole Messi state or poll locally. And the user, the coordinator will processing all the things locally and generate proof and upload to the chain. And everyone could verify it. Like we do this is because like running locally is more efficient. And the fourth one is the CLI. So everyone could like enter the CLI package and run the commands there. And the last one is the integration test. Like you can test each CLI command and also the entire flow of Messi. So let's explain like more about the whole flow. Like first of all is the sign up. So you can imagine that the coordinator deploy contracts first, and there are several contracts. I only list out 4 of them. Like And then the user can generate messy key pairs and then submit the public key to sign up to messy contract. So contract that it is dealing with the whole logic and managing the messy state. Like for example, if you are going to sign up, you could call like messy.signup. And there are factories beholden by the messy. Like the factories are deploying polls and also like message processor contracts, and we use a factory to hold it to decrease the size. And there are gatekeeper contracts. Like you could deploy a free for all signups gatekeeper, but also you could like make some restrictions to it. For example, like only the user who's holding a certain co-op could sign up. Like you could build that kind of gatekeeper by yourself. And the fourth one is the VK registry. This is like really intuitive, like just holding the V keys. So while generating the key pair, like the key pair is holding like both public key and private key, and it looks like this. It's a little bit small, but it starts with like messy PK or messy SK, like stands for public key and private key. And you will like sign up or sending messages using these keys. So while you're signing up, like you're submitting your public key, the messy public key, and also the gatekeeping data. For example, you have certain POAP, like this is kind of a gatekeeping data, and you submit it to the messy contracts, and the messy contract will check it through the gatekeeping contract, and then to see if you could sign up or not. Like everyone could only sign up once. So after the sign up period, there is a voting period. And once the user the coordinator call the messy.deploy poll, the voting period starts immediately. So there is a duration parameter there. So after the duration time, the voting period closed. So no one could submit any poll after the voting is closed. And before, like during the voting period, the user could generate messages and submit to the poll. And the messages could look like a poll, a vote, or a key changing. So let's see how it looks like. So a message is containing a command and a signature and being encrypted with an ECDH shared key generated from the ephemeral key and the coordinator public key. So like inside the command, like there are state index, which is the state leaf index where the signing key located. And then there's public key. So the state index, each user has its own state index. And the public key is the one who submit this message. And the vote option index is which option you're voting for. And the vote weight is like how much do you want to vote for the option. And then there are nonce to track the message order. So, and it could invalidate previous votes. So if you submitted like for the same like vote option, but for different weight, it could be like invalidate. And then there are poll ID and sort. So if you are submitting vote for a certain option, like mainly you're changing these two parameters. And for the public key, it would be the same. But if you are going to do the key changing, and you will modify this parameter to your new public key. Okay, so actually everyone could vote, could do the vote, could submit the messages, but only the signed up user's message would be counted. And then after the voting period end, there is final processing, like rely on the coordinator. So first of all, they need to do the merge trees. And because we are using the trees like as accumulator queue. So that's why we need to merge it. And there are two trees. The first one is the sign up tree, and the second one is the message tree. And then after merging trees, and the coordinator will build the message state locally, and then process messages locally, and this code could be found in the core package. After processing messages, you could go to the tally votes and then generate proof for both of them and submit the proof on chain. And for users, you could verify the proofs on chain, like every user could do that. Even though you are not signed up, you could verify that. So this is the accumulator queue that you can find in the crypto package. So why we use this queue is because it could subsidize gas costs and not requiring state root to be updated at its full depth. So at the end of the voting period, we need to merge the subroots. So actually, when you're running a MESI, you need some trust assumptions. So the assumption is the coordinator is honest. If not, they could publish decrypted messages, which would violate privacy, because only the coordinator and the one who submit the message could decrypt the message. And then not including a round or delay tallying, that not forcing to tally the message. And then collude with the briber will violate the collusion resistance, but even they are not honest, they still cannot censor votes, since it's all running on a pre-agreed code. And also they need to perform correct processing and tallying. Since it's running on the ZK snark, so the Circum will check all of it. So we could try it now. So if you have computer, so you could git clone our MESI repo and then install it and build it and download the test keys. And the keys is already being running after the ceremony. And then you could go to the contracts and set up the environment file and deploy config file, and then run the hard hat locally and deploy all the things locally. Try all the things locally. So these are the default Z keys. For the state tree depth, which is the allow user amount, because we use the quinary tree. So defaultly is this amount of user could be signed up. And there are intermediate state tree and message tree depth and vote option tree depth, which is really intuitive. And the default value is 10, 1, and 2. Okay, so at the beginning, you could generate your MESI key pair if you're a user. So just run the commands there at the top of this picture. And you can get the private key and public key. And then you can use the private key and public key in the following steps. And then sign up. So for the sign up, you can check out the index file inside the client package. So this displays how it's successfully signed up. And then you could publish message. Then this is the example for publishing a message for voting a certain option. Yeah, so here below is if you're publishing message after the poll ended, there will be an arrow telling you the voting period is over. So after that, you could run the merge. like for merge signups and merge messages, just as we talked about before. Like these comments are run in the client package, but since we update the contracts package, so you can also run it in the contracts package. Just run merge localhost and like insert your PO ID. Also generating proof and the tally results, you can just run the proof localhost. And well, actually there are several parameters below, like there are so many of them, so I didn't put it here. So just check out the client package or just try it. And then everyone could run the verify to verify the tally results and with the PO ID. So this page is same as I introduced this protocol. So the first one is quadratic founding and quadratic voting, which is like we also collaborate with ClearFound now to run several quadratic founding. And maybe you could build some DAO voting app or just purely voting app, vote for everything, or vote for games, vote for like who do you like, or just like, yeah, just whatever you like. And the new gatekeeper, so like now we know what is the gatekeeper, so maybe you could collaborate, like you could import the POA, import EAS, import other protocol to run your gatekeeper. And CBOL protection, so as you see, so everyone who have a messy key pair could sign up to this protocol. So what if someone like generate a lot of key pair and sign up, like make multiple sign-ups to it and break this whole system. So maybe it's a good way for you to build. And extract some of the primitives and build something else. So we like introduced before, such as the accumulator queue or some of the key pair like generating things. So if you can build things on top of it, it's also welcome to apply for the bounty. Also now we only can run the commands on our computer, on the command line. So if you build like a front end or an application for the coordinator to manage the messy runs, that's also like willing to see it. And there are several discussions inside the messy GitHub repo and more options for you to build it out. So if you have any question during the implementation or installing, feel free to ask in the Discord or check out our document. And I'll also be the mentor for tomorrow, so if you have any questions, you could also ask me. Yeah, thank you.